Principles of working of fluid energy mill. So what is the principle behind the working of fluid energy mill? To understand the concept, we should know some key points like impact and attrition and turbulent flow. So let us discuss what is the principle behind the fluid energy mill, how it is going to work. So to understand the working of this one, so we have to see this diagram. So in this diagram we can see some elliptical pipe is there, so which is present in this shape. Okay, so here what is going to happen means, so this area is called as grinding chamber. So this area is called as grinding chamber. Here is the grinding chamber. So here there are some perforations or sieve like structures we can see, through which the air with a high energy is allowed to enter. Here the air with high energy is allowed to enter, and there are some nozzles which are present here. Which is called as energizing nozzles, and this area is called as grinding chamber. So the sample which is subjected for size reduction is introduced through the feed inlet. So what happens when we pass the air with a high energy, that is compressed air, through these nozzles? What happens? The air will follow a turbulent motion because of this elliptical structure of the pipe. The air will follow turbulent motion or turbulent flow. So now what is going to happen means, due to this turbulent motion of the air in the elliptical pipe, they will lift the sample. That is, we are going to introduce the sample in the feed inlet. Here is the feed inlet. We are going to introduce the sample through the venturi injector. So what happens now? The air with a high velocity lift the samples, and it will move in a turbulent motion through the elliptical pipe. Meanwhile, what happens? So here the particles in the pipe, or the powder particles in the pipe, will collide with each other, and they can also collide with the inner walls of this elliptical pipe. So due to collision between the particles and collision to the elliptical pipe, what happens here? Both, that is impact and attrition mechanism, both are going to take place here. Impact and attrition mechanism, both are going to happen. So that is what the working principle of fluid energy mill means. It works on the basic principles, that is impact and attrition. How the impact and attrition achieved means, because of the turbulent movement of the air, through the nozzles, then due to which what happens, that will lift the sample, and due to turbulent motion, what happens, the powder particles within the electrical pipe, they undergo collision with each other and impact with the inner wall of the electrical pipe. That is collision of the powder particle to the inner wall of the elliptical pipe. What happens now? Both the mechanism, that is attrition, impact, both are takes place, due to which the particle size get reduced. Let us discuss regarding the construction part of the fluid energy mill. What are the different parts it contains? So the first one is grinding chamber. So where is the grinding chamber means? So here in the elliptical, it is present in the elliptical shape, and the product is going to grind here in this area. So this area is called as grinding chamber. So we can name this one as 1. grinding chamber. So the next one is feed hopper. The next one is feed hopper. One second. So for the feed hopper we can name as number 2. It is here is the feed hopper, you can say the feed inlet. So through which the sample is going to introduce in the fluid energy mill, that is feed inlet. And the next one is venturi injector. So here is the venturi injector through which by the help of venturi injector we are going to introduce the sample in the fluid energy mill. And the next one is energizing nozzles. Here we can see the energizing nozzles, but they are present in the nozzle shape. Is not shown in the diagram. They are present like this one. They are present in the nozzle shape, hence they are called as energizing nozzles. Energizing nozzles. And the next one is discharge opening. Here is the discharge opening through which we can collect the sample. And the next one is product collector. So here only we are going to collect the product in this area or in this part. So let us discuss in detail one by one. So the first one is grinding chamber. So grinding chamber is the part where the size reduction process is going to take place. So it is the grinding chamber where the size reduction is going to take place. And feed hopper, it is the feed hopper or feed inlet in which we are going to introduce the sample. And the grinding chamber is about it is a loop pipe with a diameter of 25 to 200 mm and the height is about 1.2 to 2.4 m. And the next one is venturi injector, which is positioned between the feed hopper and the grinding chamber. So here is the venturi injector which is going to place in between the feed hopper. This is the feed hopper and it is the grinding chamber. And the energizing nozzles. Energizing nozzles are located at the bottom of the grinding chamber. These nozzles inject compressed air or superheated steam at a pressure of around 7 atmospheric pressure. So energizing nozzles are present here at the bottom of the grinding chamber, and these nozzles will allow the air around a 7 atmospheric pressure. And the next one is a discharge opening located at the upper side of the loop leading to the cyclone separator, separates the fine particle from the dust. So here the discharge opening is located here. And leading to a cyclone separator that separates the. Here is some other device is there, that is called a cyclone separator to collect the dust particles or very fine particles we can collect in the cyclone separator. And the next one is product collector also attached to the cyclone separator to collect the product, or you can say the receiver. We are going to collect the powder particles in the receiver. The fluid energy mill. How the fluid energy mill is going to work? The first one is feed introduction. How we are going to introduce the feed. So here in this diagram we can see there is a feed inlet is there through which we are going to introduce the feed. And the material which is subjected for the grading process is introduced through the hopper and it passes through the venturi injector into the grinding chamber. So the sample which we are going to introduce is introduced through the feed hopper, and the venturi injector will control the sample movement to the grinding chamber. And the next one is particle fluidization. The particle energizing nozzles inject high velocity air steam, causing the particles to become fluidized. Whenever the feed is introduced, that is a sample is introduced in the fluid energy mill, what happens?
Similarly, in the meanwhile, in the simultaneous manner, we are going to introduce the air with a high velocity from the bottom. Here are some nozzles are there. Which will allow the air with a high pressure. These nozzles are called as energizing nozzles, and they are causing the particle to become fluidized. So from this side the sample is coming, that is the particles of the sample, and we are going to introduce the air with a high velocity. Due to both the things, due to this, what happens, the powder particles, due to high velocity of the air through the energizing nozzles, they will get fluidized, they will get suspended, or you can say the fluidized in the grinding media, that is in the inside of the loop chamber. They are going to fluidized, or you can say the suspended in the grinding area. This is the grinding area. And the next one is impact and attrition. So this is what the basic mechanism which is going to take place, by which the actual size reduction is going to happen. So here, due to this fluidization state, what happens, the powder particles will collide with each other. For example, the powder particles will collide with each other. Due to this collision, what happens, attrition will take place. Due to this collision, attrition will take place. And the next one is, these powder particles will collide to the pipe, or you can say the grinding chamber. These powder particles will collide to the inside wall of the grinding chamber. So this will leads to impact. Mechanism. Because of these two mechanisms, the size of the sample get reduces. That is, the size reduction takes place. The next one is classification. The finer particles are separated from the coarser ones and at the bend of the loop. Here some classifier is there, which is going to separate the coarser particle from the fine particles. So here we are going to place the classifier which is going to separate the bigger particle, that is the coarser particle, from the fine particle. So very fine particles get collected in the cyclone separator. So, and some coarser particle, means the particles quite larger, are again recirculated in the grinding chamber. That is what the recirculation process takes place. So finally, due to repeated collision and repeated impact and repeated attrition, the powder particles will break down and the size reduction process takes place. And finally, here we are going to place some screen where we are going to collect the desired particles. in the receiver. This is the working process of the say this one, that is fluid energy. Advantages of fluid energy mill. There are various advantages of fluid energy mill. Some are discussed here. First one is fine particle size. Fluid energy mill can produce very fine particle size up to a range of 1 to 100 micrometers. The next one is controlled particle size distribution. The mill offers a precise control over the particle size distribution, ensuring the consistency and reproducibility in the final product. So the next one is high efficiency. Fluid energy mill is highly efficient process, effectively reducing the particle size with a minimal consumption of energy. Means it will consume very less energy to reduce the particle size. And the next one is versatility. So the fluid energy mill is applicable to a wide range of the materials, including pharmaceutical products, the chemicals and food products. Disadvantages of fluid energy mill. High investment cost. Fluid energy mill are capital intensive, with a high initial purchase and installation cost. Means the purchase cost and the installation cost is very high compared to other equipments. The next one is particle agglomeration. The high energy environment can sometimes leads to particle agglomeration affecting the final product size distribution. And abrasive materials. Processing highly abrasive materials can cause wear and tear on milling chamber and components, potentially impacting the performance. Pharmaceutical industry applications. It is used in the tablet formulation. Fluid energy mill is used to produce the fine powders for tablet formulation, ensuring the accurate dosage and efficient drug release. Then, in micronization of active pharmaceutical ingredients, improving their bioavailability and enhances the drug absorption in the body. The next one is excipient processing. Fluid energy mill are used to reduce the particle size of the excipients, improving the flowability and compatibility.